Hello everyone. Today we're going to look at a tool called MCP Sentinel. AI agents today don't wait for you anymore. They call tools on their own based on the workflow defined, which is great, but right until one gets strict. That's where MCP Sentinel comes into picture. Let's look at the problem statement and how we are solving it. Suppose, what if attackers didn't hack the support AI, but they simply become one of our customers? This is a very common use case in the industry, and especially in the customer facing industry. There is a ticket that is being created from the customer, which might have a hidden message or instruction in its description saying or asking to pull up a customer's record and send it back to them or source it to them to whatever endpoint or source that they have defined. Now, the agent promptly reads the ticket, pulls the private data, and will ship it out because there would be no flag or call out from the normal English description that is being written. And every step would come back as a clean 200 OK. By this, nothing on the dashboard looks wrong, but the data is already gone. There are more complicated scenarios to this, which we'll look up in the next slide. Right now, in the industry, we get either of these two. One is the security gateway that blocks the attack but hides the evidence on its own private box. Or the other one, which is an observability tool that speaks open telemetry but only watches it happen. But to have a robust system, we need a combination of both of them. That's where MCP Sentinel comes into picture. Now, going forward, I'll show you a live demo on how it works, before which I'll just walk you through some terminologies and the components of our system through a small architecture that we have. The first one is the AI agent. It can be Gemini, Anthropic, or anything in that matter, which will interact with the tool servers that we have. In between that, we have the MCP Sentinel, which will contain the telemetry that is defined and the policy engine. Now, suppose a particular thing has to be executed. The telemetry call and the further calls are moved into the Signos architecture. And here we have a hotel collector and the ClickHouse database. Before that, we have a policy engine which will decide on whether a particular action has to be executed or not, based on the three actions that we have: allow, redact, and block. In case if it is allowed, it will go ahead and execute the get incident, get secret, or the HTTP post, whatever action is defined. In case if it is blocked, then it is never forwarded until this particular system. Yeah. So basically, what is it? What is MCP Sentinel built on? It's on Python and fast MCP. It's just a single hook. On every call, it opens one standard open telemetry span, runs the call, pass on the 5 checks that we have as defined here, right? Based on dangerous commands, loop, budget, the personal information check, and the risky sequence check that we have. Let us go to the server, and based on the same component that we saw. So these are the 3 scenarios that we have used: the SRE on call and the execution of a descriptive command and the customer support agent. Let me run this. So if we see carefully, we received an incident called INC42, which was allowed. And then we did a get secret read execution into the tool server. But later, there was a HTTP post that was defined, but this was blocked due to the already executed read sensitive action that was performed, and after which it was immediately blocked and it was not returned to the AI agent. So this is one such scenario. Like this, there can be various scenarios that can happen, as already mentioned in the previous slide. Now, this can be also observed and captured through other logs that are provided on the Signos and also through a custom dashboard that we have prepared. So as you can see here, this was the log that was captured for the last sensitive data read that happened, which captured the exact body of the request and the necessary logs that can be used to debug and action upon going further. This is a sample dashboard that we have built, which is recording the count of all the calls that happened and was executed, and we have the P95 for sample that we have, the number of calls that were blocked, and the verdict. I mean, how many of them were allowed and how many of them were blocked. We can have the graph plotted based on the time series or whatever custom requirement we need. So this is about the dashboard. Moving on. So this is a sequence diagram which consists of all the necessary components that we just discussed, which is there available on the README on the GitHub and can be referred to. And this is the MCP call that was done, which clearly logs and states why exactly the call was blocked. Suppose there are no blockers and there are no violations. This is executed as simple as how it is defined. So why and what is the importance of MCP Sentinel is this is a very common use case in the market right now where attackers come up in various ways, disguised ways. And since the industry is evolving so rapidly and leveraging AI until its maximum extent, this proves as a very vital tool for customers, and especially the use case that we have picked up for signals, which provides telemetry logs, observability, dashboards for systems where we have a customer support tool where customers write their queries through the portal. For example, if there is an integration of Jira that is there, so the description is written and things can be injected, morphed and passed in such a way that AI tools simply pick up, read and execute as per that. So even though we can have the rules defined, but the exact actions need to be scrutinized and handled in the middleware. So that is where MCP Sentinel comes into picture. And for the scenarios where there are end-to-end automations, for example, from the creation of the ticket, the AI agent picks up the description, it does the DB queries, finds out the root cause analysis, and then moves on to do the fix and creates a PR that is raised and next scrutinized by the human. And then it writes back the reply on the ticket with the required attachment, data as an attachment or as a description. So this is where MCP Sentinel plays a major role and make sure whatever personal information is there and whatever sensitive data is there of the client is not published back to the ticket or the support portal. We'll see one more scenario where an agent was asked to delete a deployment, but it was immediately blocked with the dangerous command check that we had, where on one live run, we told the agent to delete a server, Sentinel blocked it, and then the agent tried to get around the block on its own. And next, what it is doing? It went hunting for a bypass key. So as soon as we look out for a command that is blocked, next the bypass key is being looked upon and it never found it. And even if it had, sending it anywhere would have been blocked too. So what is the summary and the lesson that we have learned here is agents will route around our controls. So the guardrail that we have set up on the MCP Sentinel has to cover the whole path and record every step of the attempt. So that's it. One proxy in the middle. Every agent tool call visible is open telemetry and stoppable in real time. The firewall and the flight recorder in one span. So that's MCP Sentinel for you. Thank you.